good evening. I'm Dave Aschenbeck. I'm with Owens Corning, and I'm here tonight to talk about the Thermal House Challenge. Owens Corning got started right here in York, Ohio in the Depression. Glass companies were looking for different ways to use glass capacity, and you probably all are familiar with the Owens Corning plant just north of Highway 16 here, and they make a lot of insulation. Really, Owens Corning is a world leader in insulation capacity, which leads us to our challenge. And this challenge, in very simple terms, you get this nice scale house, and the challenge is for your students to insulate it as efficiently as they can. And we give you all the materials. Of course, there's fiberglass. There's also foam board insulation. And there's aluminum foil, which can be used as a reflective barrier. And we have what looks like cardboard. It is cardboard, but it's our pretend drywall, because the inside of our house needs to have a drywall finish. And that will be on the inside wall. And we've got tape, which can be used as sealant. And for attaching things, there's some pins in here and scissors so you can cut things up and not use razor knives, which is considered unsafe. So really the challenge is about understanding enough about how insulation works to use these materials efficiently. All these things were pre-weighed, so when the teams come in with their finished house, they have to bring the leftovers, which we will weigh, and we'll calculate what they used in there. And so it's really thermal performance ratio against the weight of the materials that they use. So there's definitely an efficiency play in there. So let's talk about insulation and what it is. And I think everyone can relate to clothing. I mean, what keeps you warm when you go outside in the winter? Any suggestions?
A coat.
A coat. Okay. So what is it about a coat that keeps you warm? Is it because it's heavy? Or what is it doing? Okay, it's keeping the heat in your body. So let's talk about how heat moves, because there's really three different ways it moves, and you really want to understand these things to know how to effectively use these materials to keep the inside of this house warm. Because the way we're going to test this is we're going to have a heat source inside this house, and we're going to measure how much energy it takes to keep it warm relative to the ambient temperature. Since we're going to be inside, we're going to keep the inside at a hot temperature where it will be at 130 degrees. And we'll see how many watts or BTUs a minute it takes to keep that in. The better the insulation, the less energy we'll require to keep that structure warm inside. And of course, this is really, really important in our world today because we need to be much more efficient with our energy. So heat travels really in three different ways. It's conduction, convection, and radiation. And conduction is just heat traveling through a material. Metal is a really great conductor. If you've ever seen a pot cooking on the stove, if you touch the outside of that metal pot with your hand, you're going to get burned because the heat is conducted in a metal very, very well. If it's a glass container, you can touch the top part of that pot and you won't be hot because glass is not a very good conductor. And so different materials have different properties. One of the best insulators at all is nothing. Air is a very good insulator. Vacuum is a perfect insulator. But how do you wrap air in between you and the cold? In our clothing, a coat, what's the best kind of winter coat you can buy? It's stuff with down. It's feathers. Are feathers good insulation? Well, not really the feather itself. It's the feather's got all this structure and it holds air. Air is a bad conductor, so it's a good insulator. And all that the feather is doing is keeping the air in place so it doesn't travel around, and that keeps the heat from traveling through that thin layer of material. So and fiberglass works the same way. It's lots of fibers. It's not quite as finely structured as a down feather, but it's next best thing. And it traps the air, and that's what makes insulation. Foam is similar. It's got little pockets of air inside of the plastic that makes up the foam. So all these things work by trapping air and minimizing conduction. So that's our first travel thing. For the house, that's really the biggest medium for heat transfer. The other one is convection. And again, going to the outside, everyone knows what wind chill is, right? Right? So it feels colder when there's air moving. So convection is like wind chill. Convection is just moving air, and that transfers heat. Obviously, if you've got, we all know heat rises. If you have a fire, you know the heat is just going straight up from that because the convection air is lighter when it's hotter, and it moves around, and it moves heat from one place to another. So in a house, if it's windy outside, you're going to have more heat transfer from the air blowing by to the walls than if things are still. So in design of the house, just trapping air and not letting it move, not having big leaks, is a big factor. If you've got a coat, there's a gaping hole in it, it doesn't matter how good the coat is here, you're going to have cold air just pouring right through, and you know, you're going to be uncomfortable, and a house is going to make it very inefficient. So sealing the house and not letting air flow from the outside to the inside or vice versa is a very important part too of making a house energy efficient. The third path is radiation. The heat from the sun, the heat from a bright light is radiation. You can feel it with your hands, you can feel it with your face. If you're near a fire, you can, with your eyes closed, you know where the fire is because you can kind of feel it. In thermal things in houses, radiation is a small player. The higher the temperature, the bigger of a player it is. But there's a lot of discussion, a little bit of debate in circles today about how important radiant barriers are, and that's what they will call something that's highly reflective. And the aluminum foil is a great example. Maybe some of you have heard about space blankets. It's kind of a survival gear thing. It's fancy aluminum foil because the heat that radiates in radiation heat transfer will just reflect off of a very shiny surface, and it won't go through. So if you're trying to keep the heat inside of a house, if you had aluminum foil on the inside of your house, that would be really good. It would reflect the heat back in. Most people wouldn't like their inside of their house covered with aluminum foil. It's not real pleasing aesthetically. So we're not going to allow, the rules don't allow aluminum foil on the inside. When we look inside, we need to see that cardboard drywall, if you will. But there's other places in the house you might choose to use your insulation. And again, there's debates among experts about how effective a reflective barrier like aluminum foil or anything shiny is. So you want to look up things and talk to people and try and get a sense for how important that is. So again, the challenge is to use these materials efficiently as possible to insulate this house on all four sides and the ceiling. The bottom will be left completely empty, and then when we're testing it, we will actually be putting it on a test board, which is totally insulated and has the heat source built in. So the bottom has to be completely naked and open, and that's how it will be tested. The challenge comes in two grades. For our middle schoolers, what I've told you is all there is. They, as efficiently as possible, dress the house, if you will. We will test it. They will give a presentation and talk about what they've learned about insulation, what's important, and what the factors are, why they decided to do it the way they did, and also the careers that are available with the kind of engineering or science backgrounds people would need to do thermal work. For high schoolers, we're also asking them to predict how many BTUs a minute it's going to take to keep that house at 130 degrees. And so the information in the packet has an introductory part that will apply to everyone, and then there's a Thermal 101, I think the last 2 pages, which goes into details and gives equations for calculating heat flow. And so when they know what they're putting in and how they're putting in their insulation materials, the information in that little tutorial should allow them to calculate how much energy it's going to take. And so there's a prediction. So we'll stack rank all the predictions from the different high school teams that compete and assign points correspondingly. So I think that's the end of the formal. There's a lot of information in the packet. On the last pages, there's some commonly asked questions. We did this challenge once before, so we repeated some of those questions, and all the answers are right in there. But again, if any other additional questions come up, my contact information is in there, and we can email things back and forth. Any additional information given to any one team will be broadcast to all the teams, so everyone will have the same information. So, any questions from our studio audience?
One of the questions my kids keep asking me, and I wasn't quite sure, was they're afraid to touch the insulation. They've always heard that it's not safe to touch, and they should wear gloves. Is that true? Or?
That's actually one of the frequently asked questions.
Okay.
And there's no health effects. It's been tested extremely thoroughly as far as whether it causes cancer and things like that. Glass fibers actually, the path where it could hurt someone would be they'd inhale the dust, and it actually dissolves in lung fluid, so it doesn't hang around very long. And nowadays, the binder is actually made from, it's vegetable byproducts. Okay, so it's a natural-based binder that's in there. Some people, the irritation part, some people are very sensitive to it, and it's a physical thing. And if they feel uncomfortable with it, for all means, wear gloves. But there's no real health things. It's more just a personal comfort for handling it.
I understand cardboard. So the inside has to be, when you flip it over, you should only see cardboard on the inside.
And tape or tacks.
Okay.
One of those three things.
Right, and the other stuff has to be on the outside.
The outside could be anything you want.
Okay.
Yeah. And again, the foam and the insulation, the floral, they can cut it to any shape they want and attach it any way they want. But just keep in mind the principles of heat transfer, and try and make it as most efficient as effective as possible. The efficiency part again will be this: we weigh the materials when they come back, and by difference determine how much is used in the house. There's a budget. I think it's $3 a house. I mean, it's all funny money, but there's formulas in there for how many cents per pound per gram each of the ingredients used. So it is used to adjust the actual thermal test results for the scoring purposes.
The other thing was they started trying to put the tacks in. They're having a hard time with the tacks. They keep bending, and
I would switch to little brads and use a little tack hammer.
Okay.
And yeah, we had several of the kits when they came back. It was pretty clear that people were using that, and that seemed to work pretty well. The only thing I would suggest, if they're in there hammering, that I would put the side that they're hammering into on a firm surface, so they don't knock the boards out.
Okay.
Just keep flipping it over to the side that they're working on.
Okay.
And they don't have to pound them in flat. They just pound them in enough to hold the boards in place, however they want to do it. Okay.
It was okay to go buy something else.
Yeah, and that's in the frequently asked questions as well. It's okay. Yeah. You haven't read it yet? Okay. I think that's it. Thanks very much.